Hey everyone, thanks so much for coming and sticking it out to the very end of Summit. I hope it's been a productive and enjoyable experience for all of you. My name is Emma Stein. I'm a solutions architect at Databricks. I've been here about 3 years, and for a year and a half of that, I was lucky enough to work with the Conde Nast team.
Hi, I'm Sarah. I'm a data engineer at Conde Nast. I have been with Conde for like 3.5 years now, and I'm mainly working with customer and subscriptions data. And today we will talk about how we are ensuring GDPR compliance for real-time data pipelines at Conde Nast.
Okay. So in a couple minutes, Sarah is going to go into the Conde Nast use case, specifically about the right to be forgotten regulation and streaming pipelines. But before we get there, I'm going to go over some of the basics. So I think everyone in the room knows what GDPR is, but for sake of completeness, GDPR is the European data privacy law that applies to the processing of all data, or all personal data, for EU citizens and residents. And it defines personal data as any data that can be used to directly or indirectly identify someone. It has a bunch of regulations in it. Some examples are the data collector, the company collecting the data, must get consent from the data subject before they collect the data. They must ensure that they specify why they are collecting the data, and to the extent possible, minimize the amount of data collected. There's also a set of regulations for the data subjects, the people that data is being collected about. So for example, they have the right to object to their data being collected. And what Sarah's going to talk about is the right to erasure, the right to be forgotten. That regulation says that if any person says to the company, I want all my personal data to be deleted, then that company has 30 days to comply and delete all of their personal data. And the data controller, the person responsible for collecting the data, not only do they have to comply with these regulations, they also have to be able to demonstrate that they are complying. So it's important that they have a set of processes and procedures and a way to audit those in the case that they need to prove that. And there are pretty serious business implications for any companies that don't comply, with up to 20 million euros for a violation, or 4% of global revenue. And probably a really large headache for you and your legal team. We'll add the disclaimer that we're not lawyers, so always consult with your legal counsel for any GDPR questions. So when we talk about the technical challenges of managing personal data and complying with GDPR in general, or CCPA, or any of the other data privacy regulations that are out there or will be out there, we can typically break down those challenges into 3 main categories. First, identifying what is actually PII. This can often be a little trickier than it sounds because it can be a subjective determination on what counts as PII. So for example, your name and your email address are always going to be PII. But if you have attributes like location and gender, those may be PII if they're tied to a specific person, but if we remove that tie between those attributes and that person, they're no longer considered PII. So it can be a little tricky to identify what's actually PII. Second, we need to determine the strategy that we want to use to protect that data. So in the next slide, or 2 slides, I'll go over some of the different strategies that can be used for protection, and then management of that data. So once we have persisted the PII, we've encrypted it, we've anonymized it, however we want to store it, we need to make sure that we're managing access so only the people that need access are able to see it, and that we can also audit that access. So of course, 3 problems sound simple, but we can break each of those problems down into a much longer list of questions. So for example, for identification, what if our schema evolves? How do we make sure that we're getting any of those new columns? What if we have an undefined schema and new types of data is coming in all the time? How do we identify that new PII? In terms of protection, we need to determine, is there actually going to be value to storing this data, or can we just remove it? And if there is going to be value, will anonymizing that data diminish the value? So a lot of questions to reason about there in terms of protection. And then in terms of management, possibly the longest list of questions in terms of who needs access to that data? How do we ensure access at the file level and table level and for unstructured data? And then how do we audit that access, as I said? So in terms of the different strategies, Unfortunately, you can't really recommend one blanket strategy in terms of how to protect your data because it really has to be use case and persona dependent. So you really want to think about how you're consuming that data and then work backwards. So obviously the safest strategy is just to remove that PII. So if you have PII coming in and there's no clear value for downstream use cases, we're always going to recommend that you remove it. That's the safest option. But in a lot of cases, of course, you are going to need that PII. It's going to provide some value to your organization. So the next step that you could consider is, can I anonymize that data? So as I was saying, if you have several attributes about a person, but you can't link them to an individual person, then that's no longer going to fall under the regulations of GDPR. So we could anonymize that data. So we replace it with an anonymous identifier. And then the downstream management of that data is going to be much easier. But again, in a lot of cases, we're going to need that process to be reversible. So we're going to need at some point to take that data and rejoin it with the actual personal data. Maybe our call center agents need it, or we need it for some kind of billing purpose. So another option that Sarah's going to give a much more detailed example on is pseudo-anonymization. So in that case, we'll take the personal data, we'll replace it with some kind of pseudonym, and then we'll take the personal data and we'll store it in a highly restricted table. So only a very small number of people will have access to that, and that'll be highly governed, and the rest of the data can maintain or stay in the main table. And then finally, obviously, the last option is clear text. We want to avoid that whenever possible. Okay, so you've probably seen this medallion architecture diagram all over the conference. As data's flowing through to the different layers of data, we're incrementally improving the quality. So you just want to have a way to keep track, again, how your PII is flowing through. So in the bronze layer, you're more likely to have PII data coming in the raw layer, but in your gold layer with your business level aggregates, it's probably just a summation, and you wouldn't have PII there. So you have to think about how the data is flowing through and who has access to the different layers. All right, so how does Databricks help? Again, if you've been here all week, these are similar themes that I'm sure you've seen throughout. The first one, single source of truth throughout the organization. The less copies of data that you have, the less risk that you're going to have. If you have a situation where data scientists are downloading the data to run tests locally on their computer, you're multiplying the risk every time that PII gets downloaded to a local laptop. So having that single source of truth reduces risk, and it also allows you to have a single set of processes to manage, identify that PII, which is going to simplify things, especially from an audit purpose. Second, we know managing and governing object storage and files is a classic problem for data lakes. So with Unity Catalog, we're going to talk about how you can use that to discover, manage, generate lineage, and all of that. And then finally, something that I haven't touched on much yet is the actual technical challenge of updating and deleting data. So GDPR requires that we keep personal data up to date as much as we can, and that we also deal with that right to be forgotten rule. So we delete the data whenever requested. And that actually presents a lot of technical challenges when dealing with files and object storage. Okay, so Unity Catalog, as you've been hearing, and I'm sure you heard it in the keynote, our goal with Unity Catalog is to give you unified visibility into all of your data and AI assets, whether those are stored and managed in Databricks or managed elsewhere. So the first aspect of Unity Catalog that I think is most relevant to GDPR is a single permission model on data and AI, the ability to govern not only tables, but also at the file storage, models if those contain PII, and so on. And also the ability to do fine-grained access control, row level and column level masking. Common example we see is region-based control. So for example, your European call center agents, maybe you only want them to see data on European customers. You can easily do that with the row-based access control. The second aspect of Unity Catalog that I think is relevant here is the discoverability and the classification aspect. The auto-generated lineage is going to be crucial for tracking how PII flows through your system. Without that, it's going to be a tedious process of having to go through your jobs and your notebooks and identify where that PII flows. All right, so the last aspect was Delta, and how does Delta help? So if Sarah sends in a request that she wants to delete all of her personal data, we're going to have to go through, we're going to have to identify all of the files that have data about Sarah. And then since it's object storage, we're going to have to completely rewrite that file, removing the rows containing Sarah's data. So that can be a pretty inefficient process. So if you know anything about Delta, you know that one of the key innovations of it a couple years ago, when we released it a couple years ago, was ACID compliance. So that solves the challenge of reliability and not interrupting any readers while we are rewriting that data. So that's one challenge solved. The next challenge is how do we actually find the rows of data that contain, or the files that contain Sarah's data? Obviously, the fewer files that we have to open, the more efficient that's going to be. So features like Z-ordering, liquid clustering, obviously partitioning help with that. And then in terms of actually making those updates, features like deletion vectors and low shuffle merge are going to make that more efficient. There's an example on the right of the slide of how deletion vectors work. So for example, if we say we want to delete row 4 in that image, typically we would have to rewrite that entire file at the time of the delete. With deletion vectors, we can just put an indicator in the Delta log that row 4 should be deleted. It won't be returned in any queries. And then later on, we can clean up all of the files at once for any deletes that have happened during that time period. So that allows us to remain compliant while also making it a more efficient process of deleting and updating. OK, so back to the medallion architecture. I'm going to pass it over to Sarah in a minute. And she's going to talk a little bit about how this changes when we have a streaming architecture. So let's say we have a batch pipeline. Sarah puts in that request to delete her data. OK, we can delete it from the bronze layer, and we can pretty easily cascade that down. We can go to Unity Catalog and see all the dependencies at the column level of how that's going to affect our pipeline. But what happens when we have streaming, right? Streaming is an append-only architecture. So if we try and delete from the bronze layer, that's going to break our pipeline when the silver table tries to update. So Sarah's going to talk about that.
Thank you, Emma. So before that, let me briefly introduce Conde. So Conde Nast is a global media company, and we are home to many iconic brands such as Vogue, Vanity Fair, New Yorker, GQ, Wired, and many more. And I'll start with an overview of Evergreen, which is our unified lakehouse we have at Conde Nast. So as you can see, we have different ingestion points from Confluent to Kafka. Some of our data is internally sourced, and others are ingested from like third-party solutions. For data processing, we use Databricks, and we have a mixture of real-time and batch pipelines at Conde. So we store our tables at S3 in Delta Lake format, and we have managed tables on top of them using Unity Catalog. So we use dbt for transformation and Airflow Astronomer for scheduling the pipelines. We also have downstream tools we use for sharing the data we have with other teams for different use cases. So examples of that are for analysts, we use Mod, SailTree for email campaigns, and ActionIQ for marketing campaigns. As GDPR compliance is a very broad topic to cover during this session, we will actually focus on mainly 2 pillars. Few things to take into consideration while handling PII are identifying the PII, encryption, and access management. So we will briefly mention and talk about this. Another pillar we will mostly be focusing on for the rest of the presentation is right to be forgotten. We first need to map and audit the data to understand how and where we are actually storing PII. This also makes it easier to locate and delete data when we receive a request. When deletion is not feasible, we can anonymize the data, which means we can remove the PII out of it, but keep the rest of the non-PII portion so that we can use it for different purposes like analysis and record keeping. It's also important to implement automated systems to manage and respond to deletion requests efficiently within the GDPR required timeline. Lastly, there are situations where organizations are not actually required to delete data, such as for compliance with legal obligations, financial records, and so on. So please discuss this with your legal team to see if this would apply to your case. Also, please note that Emma and I are not legal representatives. So when you're addressing the privacy governance compliance can be very subjective to each company and the data set they are working with. So please do not take this presentation as legal advice and seek help from your legal team to discuss how to best implement regulation solutions for your specific case. Okay, to set some background, here's a quick overview of how did the real-time pipeline initially look like when we first started exploring how to implement privacy deletions on streaming pipelines at Conde. So as you can see, we are following medallion architecture, and we ingest from Kafka. Before writing the bronze table, we were encrypting and hashing the PII using an internal library we created and maintaining. This way, we make sure we would not keep any PII plain text PII on our tables and have a unified, reusable approach through the other pipelines. After the encryption, we write the raw version of the data to bronze layer, and for the silver layer, we read the newly appended data from the bronze layer with the help of checkpointing and transform and write this data to silver tables. Using DPT with a daily job, we create and update aggregated gold layer version of the tables. And depending on the use cases, stakeholders can, for example, dashboards or analysts, they can either query the silver tables or the gold layer tables. Also, I want to give a brief overview of the nature of the data we were working with. So conversation around the privacy deletions on real-time data pipelines at Conde started with a pipeline related to subscriptions. This pipeline has many of the tables with different PIIs all over the place. And also due to the nature of the project, we are working with dynamic data prone to changes. We receive different events from the same Kafka topic. So we have one bronze table, but we create multiple silver and gold tables out of that one. The data ingest we ingest from Kafka is a mixture of internally sourced and third-party data, which means we don't actually have a defined schema on top of that specific pipeline, and this makes it harder to identification of the PII, make it more challenging. So what are the challenges of implementing GDPR compliance in real-time data pipelines? So first of all, updates and deletions on streaming pipelines are not easy to implement. As Emma said, medallion architecture is insertion-friendly, since the idea behind it is that you process and insert the incoming data to each layer. It's not for scanning and updating, it's not for scanning tables for updates and deletions and find those on the tables. So the question is, how can we capture and carry over those updates and deletions from one layer to another? Another challenge is how to do these updates and delays without disrupting the real-time processing. Delta Lake normally does not allow multiple jobs manipulating the same table concurrently. How can we work around this? Also, we do not want to break checkpointing while updating these tables. An option can be stopping the stream and to do deletions, but this is not a feasible option because it's lots of manual efforts in the long term, and it still does not actually solve the checkpointing problem. Lastly, we want our solution to be scalable and flexible. We want to design a robust, scalable, flexible solution and minimize manual efforts for management. So this is our first proposed solution. So the idea behind it was to how can we address the challenges on the real-time pipeline we discussed earlier with minimal changes and fast implementation. Firstly, we decided to not delete data, but anonymize it since we need to retain non-PII data for reporting purposes. We received the emails of the customers, as you see on the bottom right corner, that requested privacy deletions and scanned the bronze table to pinpoint the data that needs to be deleted or updated to be anonymized. We update the data to remove PII fields of the customers on the bronze table, and we use change data feed to capture these updated records and propagate these changes between the layers. In a case where where we would not be using Delta Lake and we didn't have access to a change data feed, we could implement also alternatively solutions ourselves, such as flagging updated records, scanning and updating each table, each layer separately, or actually implementing a change data capture solution similar to change data feed ourselves. Also, thanks to partition pruning feature of the Delta Lake, it is actually possible to do updates on the historical portion of the tables without stopping the streaming flow of incoming data. Lastly, this process is, as you can see, fully automated, running periodically with minimal interventions. Let's go over an example to see how does change data feed actually works. Let's assume we have a simple bronze and silver table. We have an example related to subscription data for the relevance, where each row represents a customer and their subscription status together with additional information. Bronze table is the raw data we ingested. On silver table, we make transformations and create additional columns out of it. For example, the email domain column out of the email column. On silver table, please also note that for the demonstration purposes, we kept the PII as plain text and we didn't encrypt them. So here we have an example scenario of right to be forgotten request. In this scenario, Charlie says he wants his PII to be deleted from our systems. So how should we implement change data feed on bronze layer for such an example? Firstly, as you can see on the first line, we need to enable change data feed property for the bronze table. And we need a merge statement for making updates on the bronze table. So as you can see on the merge statement, we have a match statement to find and pinpoint the Charlie's data on the bronze table. And then we have an update portion of the merge statement where we are actually overwriting his PII field with a default value. This table shows an example of what change data feed looks like for the bronze table after it is enabled. As you can see, there are 3 additional columns: change type, commit version, and commit timestamp. By looking at these columns, we can actually detect updates and delays on the table together with timestamp and commit version of it. So this is actually very helpful because as you can see, we have the pre-image and post-image of the updates of the records, and we can actually see which records has been updated. So the next step is how can we read these updates from the change data feed of the bronze table and merge it into the silver table. We need to filter out post-image version of the records from change data feed of bronze table, and this will give us the records that has been updated. And we can write these changes to silver table with a merge statement like in this example, which is very similar to what we did on the bronze job. So again, we have a match statement for finding the IDs, finding the records that needs to be updated. We are using ID for this example. And on the second portion, you can either update the whole record, or you can actually, if you know the name of the columns of the PIIs distinctively, you can just change them as well. So this proposed solution addresses most of the challenges we talked earlier. We can do updates and deletions on the streaming pipeline and actually propagate these changes between the layers. And we can do it without disrupting the real-time flow. But is this an optimal and flexible approach? Unfortunately, no. This solution is not scalable. Because we need to scan all the data we have so far on the PII, on the bronze table, to be able to anonymize it, and also find the data we need to anonymize. So this will get only more and more expensive on the long term, and it will become very hard to maintain in the long term. Also, we are making updates on lots of partitions and change raw data, which is a risky move. So the question is, how can we avoid this? Problem is the way we set up our table, so let's take a step back and remember the concept of pseudonymization. As Emma mentioned before, pseudonymization is a data protection method that replaces personal identifiers in data with pseudonyms. So we have an example here where we placed PII data of the customers onto a lookup table and assigned a random value to each of them to connect with the bronze table. In this case, bronze table is pseudonymized since we do not have any PII on it, but we can retrieve this information by joining with the lookup table. Could this concept help us to come up with a better design for privacy deletions? Yes, the answer is yes. Based on the concept of pseudonymization, we decided to restructure our tables and create something we called user vault. So what is user vault? Taking from the concept of pseudonymization, we separate PII fields out of the tables from the data and keep them on a secure vault. Separation happens before writing the bronze layer, which means bronze, silver, and gold layer does not have any PII data on them anymore. This enables us to handle PII differently from the rest of the data and also implement further safety measures on it. For write-to-be-forgotten process requests, we only delete PII entries from the user vault and do not need to touch the main tables anymore, which is cheaper and safer solution. This addresses the scalability concerns we had with the previous design, saying that this approach requires a commitment and potential restructuring of all pipelines that have PII. Let's take a closer look on how user vault looks on the bronze job. After reading from the Kafka, we call a function for user vault. In this function, we assign each record a unique ID. Then we separate PII fields on the data frame. We encrypt and hash these PII columns depending on the use cases we have and write them down to the user vault with that unique ID. Lastly, function returns back non-PII fields together with the same unique ID which gets written to the bronze table. This way, we are actually keeping the linkage between the bronze layer and the user vault data. PII fields that the function will separate can be fed into the function manually, or you can be detected automatically with the help of ML. Let's go over an example to see how does deletion request for child would work in this case. Since all PII of the child is actually on the user vault table and there is nothing that needs to be deleted on the bronze table anymore as part of the right to be forgotten, we only need to delete entry for child from the user vault to be compliant with GDPR. We call this approach anonymization, as there is no way to retrieve and connect PII of the child with the data on bronze, silver, and gold layers, so his data is anonymized. A quick note in here is that to be considered successful with anonymization, we need to make sure there is no way to retrieve back Charlie's PII and link it back to the data we are actually keeping. This means we need to take other data sets we have and the data in third-party tools and solutions into consideration as well. So what are the advantages of the user vault? So first of all, we quarantine the PII data, and this gives us the capability to implement enhanced data integrity, security, and transparency solutions on top of it. And also, we can have more advanced access control policies on it. Also, and on top of it, we will have a more optimized right-to-be-forgotten process. So what are the next steps and current challenges we have at Conde Nast? So we need to automate the PII identification process. We have to be able to actually call this process fully automated, flexible, and scalable system. Because today, what we need to do is like manually identify those PII fields and actually tag them and like put it onto the user vault function. So we need to migrate data we collected so far to user vault and figure out how can we optimize this process because it can be very expensive. And we need a contingency plan for addressing instances where PIIs goes undetected and is actually transferred to the main tables. We need a plan for how can we fix those situations efficiently. We're also working on exploring how can we optimize user vault for reads because we are actually introducing another join to the queries who needs to access the PII data. And we are expecting Liquid clustering to help with this issue. So I will pass it back to Emma.
All right, just a couple more things that are either in preview or about to be in preview on Databricks that I think are relevant here. Okay, so first, automated data classification and tagging. So I talked in the beginning about the difficulty of identifying PII. We've built a new feature into Lakehouse monitoring that's going to try and automatically detect and tag any new PII columns in your data, and then you'll be able to easily view and search by those tags in the Catalog Explorer. So it'll look something like this, where as the data comes in, if you enable it on your tables, the tags will be automatically added, things like PII email, what are the other, phone number, and so on. Another feature that I'm really excited about is attribute-based access control. I think you guys saw this in the keynote. But the ability to take those tags and then add governance based on them. So for example, if you tag all of the columns that have a social security number in them as social security number, then you can apply the same rule to all of them. So it's going to be much easier to organize, mask, and restrict your PII that way. So putting that all together, the way that this could work with these two new features is your data steward or someone involved in governance would apply a rule. So on this slide, it's applying a rule that when the tag equals the phone number, mask everything except for the last 4 digits. Then your data engineer, they build a new pipeline. That pipeline contains a field with the phone number. So they either tag it, or even better, the automated tagging within Lakehouse Monitoring tags that field as phone number, so that when a user goes to read that data, that policy of masking is automatically applied without the data engineer or the data steward having to come in and do anything additional. So very excited for that to happen. And with that, I think that's all. Thanks everyone for coming.
Yeah, thank you for joining us.
Hope you enjoyed it, and we'll be around if you have questions.